Okay, so gradient of a curve and angle of inclination of a tangent. So the gradient of a curve at a particular point P on it is defined to be the gradient of the tangent at P, okay? So the gradient of a curve at a particular point is defined to be the gradient at the tangent. Okay, the gradient of a curve at P is thus the value of the derivative at P. So what we can do is we can look at the steepness of a tangent, and it can be expressed either by giving its gradient or by giving its angle of inclination. Now remember earlier we looked at the angle of inclination being the tan alpha is equal to the angle, okay, so we'll be having a look at that, or we could also use the gradient, so we could be asked for either one. So what we might quickly just write down, okay, is, if my screen is going to work for me, is the gradient, okay, so the gradient of a curve at a point P on it is the gradient of the tangent at P. Okay, so basically all this is saying is the gradient of a curve at a point P on it is the gradient of the tangent P, or at P. Okay, and the second thing we're going to write down is the steepness. Okay, so the steepness, so you're thinking angle with steepness, the steepness of a tangent, and we'll have a look at an example of this in a sec, can also be expressed, okay, because if you think of steepness, you think of, well, how steep, or what's the angle it makes? Angle of inclination, okay? So let's have some look at some examples of those. So we're going to start off by differentiating a f of x, geez, I can't even speak. We're going to start off by differentiating f of x is equal to x minus x squared. We're going to find the gradient and angle of inclination of the curve at the origin. We're going to find the gradient and angle of inclination at the point 2, 0. And I'm going to sketch the curve and the tangents marking their angle of inclinations, okay? So let's start off by differentiating this. So we learnt in the last video how to differentiate a linear combination. So this is a parabola, which is just a linear combination of two functions, okay? So my derivative, and we're just going to do it the short way. So derivative of 2x is just 2, okay? Minus derivative of x squared is 2x, okay? So our derivative is 2 minus 2x. Okay, our next step is to find the gradient and angle of inclination of the curve at the origin. Okay, so if we're looking at the origin, so at the origin, OO, okay, gradient is, okay, so to find the gradient, we're going to write, so gradient of tangent, so we're looking at the derivative at when x is equal to 0. Okay, so if we substitute 0 into our derivative function, it's just 2 minus 2 times 0, well, that's just equal to 2 then. So our derivative there is 0. Okay, and then we're going to find the angle of inclination. So what we're going to do is we're going to let alpha be the angle of inclination, okay, of the tangent. So then we get tan alpha is equal to 2, okay? And we're only talking about in a situation where alpha is between 0 and 180 degrees, okay? Because think about the gradient of a graph. It's only going to be between 0 and 180, because we only look on the top side, okay? So just using the inverse tan, we get, so if tan alpha is equal to 2, we take tan inverse of both sides. Okay, so tan inverse. Okay, so we're going to get alpha is equal to, so the tan inverse is, we'll go 63 degrees, and we'll go to nearest minute, so 26 minutes. Okay, so just to verify that using the calculator, shift tan, okay, and we're going to put 2 into there, and there we go, 63, 26. Cool. Okay, so it's part B. Now, part C, so I'm just going to quickly write this down. Part C says find the gradient and angle of inclination at the point A20. Okay, so again, we're going to be finding the gradient, but at this time at a different point. So we're going to write at, so the point this time is going to be 20. Okay, the gradient. So the gradient, so let me just double check, yep. So the gradient of tangent, okay, the gradient of the tangent is equal to, and we're going to substitute it into our derivative, so f dash of x, and this time we're doing it where x is equal to 2 down here. So my derivative at x is equal to 2, well, that becomes 2 minus 2 lots of 2, so that is equal to -2. Okay, so pretty easy, that one. Okay, now what we're going to do is we're going to find what the angle of inclination is. So this time we'll let beta be equal to the angle of inclination of the tangent. Okay, so then going through the same processes, then tan of beta is equal to -2. Okay, to get the beta by itself, we're going to take the inverse tan of both sides. Okay, so tan -1 of -2. Okay, so we're going to get beta is equal to, and we're going to do tan -1 or inverse tan of -2, and we're going to get -63 degrees, okay? Or if we add that to our 180 to get our obtuse angle, it's going to be 116 degrees and 34 minutes. So 116 degrees and 34 minutes. Remembering we have to add 180 degrees to it, okay, because it's between 0 and 180. So, you know, if we're going backwards, then we have to flip back the other side, okay, just using that. Okay, now part D, last bit. So part D is to sketch the curve and the tangents, marking their angle of inclination. Okay, so the curve that we've got in this case, okay, is a negative parabola. Okay, and the roots of this parabola are at, well, we know where they are because they've actually been shown to us. They're at 0, 0 and 2, 0. So 1 is here and 1 is here. Okay, and 0. Okay, and what else do we know about this? Well, we know that the angle of inclination, so that is that the tangent, or the angle that the tangent makes at this point here, is our beta, which is equal to 116 degrees. Oh, that was bad. 116 degrees in our 34 minutes. And the angle of this one here, so the line here, which is this one here, which is our alpha, is only equal to 63 degrees and our 26. So 26, okay. So we know it's something like that. Okay, so now what we can do is we can draw our graph on here. I'm going to use green for this one. Okay, so what we could do is we could say, well, halfway between there is 1, substitute that into our original equation to get 2 times 1 is 2, minus 1, so it's just 1. So my turning point is here, and our graph goes down like that. Okay, and you can kind of see that our tangents, okay, make that angle like that, and our angle like that, okay? So that's how we work out the angle of inclination and the gradient of our curve, okay? So we're going to have to use some of that sketch curving stuff that we've been doing to be able to draw these, okay? But with that being said, that's pretty much it for this section of the topic, okay? And we're going to have a look at how to do the how to find points in a curve with a given angle of inclination in our next one.